Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 10 of 21. Sometimes a single row of data contains an array of hidden records, and you need to detonate that array to analyze it properly. Transforming and reshaping data is how you unpack, format, and structure that information for downstream processing. When you need to modify a data frame in PySpark, you do not change data in place. Data frames are immutable. Instead, you create new versions using a method called withColumn. This method takes two arguments. The first is a string representing the name of the column you want to create or replace. The second is a column expression defining the actual data. If you provide a name that already exists in the data frame, PySpark overwrites the original column. If the name is completely new, PySpark appends the new column to the right side of your dataset. To define what goes into that new column, you typically use PySpark built-in functions. These are imported from the SQL functions module and provide highly optimized operations that execute across your entire cluster. Consider string manipulation. Text data from external sources is rarely perfectly formatted. You might have a column containing usernames written in an unpredictable mix of uppercase and lowercase letters. You can fix this by passing your existing column to a built-in function like lower, which forces all text into lowercase. Alternatively, you can use a capitalization function to ensure the first letter is uppercase and the rest are lowercase. In practice, you build these operations directly into your data frame transformations. You call withColumn, name your target column, and assign it the result of the lower function applied to your input column. PySpark evaluates this expression for every single row. You can string multiple withColumn calls together to apply several transformations sequentially, passing the progressively updated data frame to the next step each time. Now, the second piece of this is reshaping. Cleaning strings changes the values, but what happens when the fundamental shape of your data is preventing analysis? This is where it gets interesting. You might receive a dataset where a person's identifier is in one column and their monthly incomes for the entire year are packed into a single array in the adjacent column. You cannot run standard relational aggregations on a nested array. You need each individual income value on its own row to calculate averages or find minimums. You solve this structural problem using a built-in function called explode. The explode function specifically handles arrays and maps. You call withColumn, specify the column name you want for the output, and pass the explode function wrapping your array column. PySpark executes this by taking the original single row and tearing it open. If the income array contains 12 distinct values, explode generates 12 entirely separate rows. In the new data frame, the target column now holds a single flat income value per row instead of a list. Crucially, PySpark duplicates all the other columns from the original row. The user identifier is copied exactly across all 12 new rows. The logical relationship between the user and their income remains perfectly intact, but the data is now flat. You have reshaped a nested structure into a long table ready for standard grouping and filtering operations. The true power of PySpark transformations is that functions like explode and lower do not just manipulate individual values, they define a logical computation plan that scales instantly whether you have 100 rows or 100 billion rows, without ever requiring you to write a single manual loop. That is your lot for this one. Catch you next time.